purpose of this design project was to implement the theories learned in class about induction and Faraday's law by building a real-world application whose function was derived using these principles. The project that I decided to design and build was the wireless power transfer. And true to its name, this is a device that works to wirelessly transfer power from a powered transmitter to a nearby unpowered receiver. To achieve this function, the device takes advantage of the principles of the Biot-Savart law, induction, and Faraday's law. The transmitter of the device works by running a non-constant current through a coil of conducting wire, and as a result, this induces a magnetic field surrounding the transmitter. But more importantly, this induced magnetic field is constantly changing due to the non-constant current. The wireless power transfer constructed in my particular design project is powered by an alternating current. So for this application, to be more specific, I can say that the magnetic field surrounding the transmitter is constantly changing direction. This works to power the nearby receiver coil because a non-constant magnetic field results in a changing magnetic flux through the area of a non-powered second coil. Through mutual inductance, this change in flux would be opposed by an induced EMF in the second coil in the direction which opposes the change in net magnetic flux. The result is an alternating current being generated wirelessly in the receiver loop of this system. The second loop can then be attached to loads, essentially powering other things wirelessly. To physically implement this project, I constructed the transmitter by coiling a copper wire into a circular loop and attaching both of its ends to an AC source. I chose to create the transmitter with copper wire because it's a good conductor and has low resistivity, which will allow for a larger magnitude of current to run through the coil of wire, thus creating a larger changing magnetic field and resulting in a larger power transfer. I chose to use a circular loop because its geometry made it easy to coil, simple to mathematically model, and easy to locate the perpendicular path of the changing magnetic field, so that I could maximize the magnetic flux through the area of the receiving loop by placing it along this path. An alternating current was chosen as the source because a changing current is required in the transmitter for the device to function. In an alternative design, this was achieved using a direct current source and a transistor. But an AC source will actually cause a larger change in current because it's reversing direction rather than just turning on and off, as well as no additional components were needed for the wireless power transfer to function, so it was simpler. Therefore, the AC current source was chosen. To construct the receiver, a second copper wire was coiled similarly to the one in the transmitter. The material and shape of this coil were chosen for the same reasons they were chosen earlier. To display the power being induced in the second coil, both ends of the coil where the charges have built up and the potential difference across the wire occurs, an LED was attached. In other designs, as mentioned before, I had considered using a DC source and a transmitter to create the non-constant current in the transmitting wire, but for reasons already explained, I decided that an AC source was the way to go. Other designs also included resistors attached to the transmitting wire, the receiving wire, or both. This was ultimately not included in the design because a larger resistance in the transmitting wire will work to reduce the magnitude of the current running through the wire, which in turn reduces the magnetic field surrounding the wire and results in reduced power being transferred to the receiver. And no resistors were attached to the receiving wire because that would reduce the amount of potential difference across the LED that I wished to power. Ultimately, the design chosen worked well and can be seen in this video lighting up an LED.
Oh, look there. I wonder if my coil is too small. Okay.
Thanks for listening, and thanks for an amazing semester.